Okay, so I'm just going to run through a couple of notes and an example for exercise 5.4, which you can watch over the holidays. So exercise 5.4 is reducing balance depreciation. This first page here is just a couple of notes that you'll need as you're going through. So we just have a definition of reducing balance depreciation. We have how it is modeled using recurrence relation, and then down here how it's modeled using a general formula. Now the example I'm going to do, it's worked example 6 from page 278. I've changed the wording of it a little bit just to kind of recap flat rate depreciation within it as well. Okay, so worked example 6 from page 278. A transport business has bought a new bus for $60,000. The business has the choice of depreciating the bus by a flat rate of 20% of the cost price each year, or by a reducing balance rate of 30%. Now we've covered flat rate already, but I'm going to recap that here in part A. Alright, now obviously your key terms and your keywords, you want to underline those as you go along. Key one here is depreciating, which means that we're going to be going down in value. Alright, part A asks us to set up a recurrence relation to model the flat rate method. Okay, so recurrence relation to model the flat rate method. I'm going to have V naught, which is my initial term. So my initial term here, my starting point, is $60,000. I'm going to have something that represents, so let me just give myself a little bit more space here. I'm going to have something that represents the next term, so Vn plus 1 equals, I need to say what's happening each time. Okay, so with the flat rate method, if you recall, we come down in price by the same dollar value each time. Okay, by the same dollar value each time. Okay, so Vn plus 1 equals Vn minus, alright, 20% of $60,000. Okay, so 20% of $60,000. So that's the dollar amount that you're going to come down by every year or every time period. Okay, now 20% of $60,000 on your calculators works out to be $12,000. Alright, so set up a recurrence relation to model the flat rate method. I've got an initial term, $60,000. Okay, so V naught equals 60,000. Vn plus 1 equals Vn minus 12,000. Okay, so I'm going to come down by $12,000 every year. Alright, now that's the flat rate method, and we've covered that already. The new stuff for today is this one here. Okay, so set up a recurrence relation to model the reducing balance method. Alright, now the reducing balance method is different. Okay, so with the reducing balance method, you're going to come down by a percentage every year. So you're going to come down by the same percentage every year of the previous year's value. Okay, now we can see that model back up here. Okay, so this is the general recurrence relation I'm going to be using, and here's my definition here. Okay, so a fixed percentage of the current value is lost each year. Now it does look different, so we still have our Vn plus 1. We're still going to have a V naught. Okay, so we're still going to have a V0, an initial term, but the difference this time, instead of coming down by the same dollar amount, we're going to come down by the same percentage. Okay, now that's the big R here. Okay, so what the big R is, 1 minus that percentage over 100. Okay, 1 minus that percentage over 100. So for example, if I'm coming down by 20% every year, that big R is going to work out to be 0.8. Okay, so you're coming down by 20% every year. If I was coming down by 25% every year, that big R would work out to be 1 minus 25 over 100, which is 0.75. Okay, now that's a big change to get used to. Alright, now let's go down and look at our example. Okay, so we've got our flat rate method set up already. So now we got to set up our reducing balance method. Okay, now initial term, alright, so initial term V naught equals 60,000. Alright, that's the same as the one before. Okay, so we've still got the same start point, which is $60,000. Alright, now the difference this time, Vn plus 1 equals, all right, now that big R, okay, so the big R, so it's 1 minus the depreciation rate over 100, okay. My reducing balance depreciation here is 30%, okay. Reducing balance depreciation is 30%, so it's going to be 1 minus 30 over 100, which is going to work out to be 0.7. All right, now that's the big difference between flat rate and reducing balance. Flat rate up here, we're coming down by $12,000 every year. You're coming down by the same dollar amount every year. With reducing balance, you're coming down by the same percentage of the previous value each year. So every year you're losing 30% of your value, so 0.7, okay. So because you're coming down by 30%, that's why it's 0.7, 1 minus 30 over 100, okay, 0.7. So do I have my three parts that I need for a recurrence relation? I've got an initial term here, I've got a next term here, and I know what's happening each term. Each term is going to get reduced in value by 30%. All right. Now, draw graphs for both methods on the same axis for the first 5 years. All right. I'm going to head over to my calculator. Okay, so let's get our terms for the flat rate first. Okay, so with flat rate, $60,000 is your initial value. I'm going to type in 60,000. I'm going to hit enter, and your recursive part is what's happening each time. Okay, so in the flat rate method, you're losing $12,000, the exact same dollar amount each time. So every time I hit enter now, okay, I'm coming down by $12,000 until I happen to hit 0 for this example. It's not going to happen every time. That's just for this example. Okay, that was the flat rate. Now, reducing balance, $60,000. Okay, I'm going to hit enter again so the calculator remembers that. Now, reducing balance depreciation means I'm coming down, all right, and if you remember it was 30%, I'm coming down by 30%, so I'm going to times by 0.7, all right, because I'm coming down by 30% every time. So what's happening there is that number has been reduced by 30% to give this number. That number has been reduced by 30% to give this number, and so on. That number reduced by 30%, reduced by 30%, reduced by 30%, and so on. Okay? So when we go to draw our graph, here's our numbers for our reducing balance. And back up here, these were our numbers for our flat rate. Okay? Now I've gone and worked ahead a little bit, and I've just filled those numbers in. Okay, so at the start, the bus or whatever we're talking about is $60,000. Okay, so flat rate 60,000, reducing balance 60,000. Okay, we can see here with our flat rate that it's coming down by $12,000 every single time. Okay, that number doesn't change, $12,000 every single time. With our reducing balance, we're coming down by a fixed percentage of the previous value each time. So that gets reduced by 30%. That number then gets reduced by 30%, reduced by 30%, reduced by 30%, and so on. All right. Now the question asked us to put that information on a graph. So Control I, add data and statistics. Okay, so year 0 to year 5, and I'm going to put in my flat rate first because we've seen this before. Okay, so with a flat rate depreciation, you get a straight line graph, and the reason why you get a straight line graph is because you come down by the exact same amount every time. Okay, so you're losing $12,000 every time. I'm going to go menu, top properties, add y variable. Flat rate's already there, so I'm going to put in reducing balance. Okay. Now the major difference you'll see here is that flat rate, which is the blue dots here, that produces a straight line the whole way down. My reducing balance depreciation does not. Okay, so what happens is you get a curve like this. Alright, and that's how you know the difference graphically between reducing balance and flat rate depreciation. So let's look at what we've answered so far. So part A, we set up a recurrence relation for flat rate. Part B, we set up a recurrence relation for reducing balance. Remember the key part here, 0.7. You're reducing by 30%. Okay, that's the key difference. We've drawn our graphs of the future value against time for both methods. Okay, here's our graphs of future value against time for both methods. And the last part of the question, after how many years does the reducing balance future value become greater than the flat rate future value? Now we can look at that on the graph, or we can look at it back in our table of values. Okay, so in this section of the graph here, so blue dots here, so the flat rate value is more than the reducing balance, more than, and then here's where it switches. Over down here. Okay, so reducing balance value is greater here. We can also see that from back here. So flat rate is more for year 2. For year 3, the flat rate is still more, and then for year 4 is where the changeover occurs. Okay, so in year 4, the reducing balance value is greater. So back here, after how many years does the reducing balance value become greater than the flat rate future value? That was 4 years. Now, just based on that example that I've done, you should be able to answer question 1 through 8 from exercise 5.4 and question 13 and 14 as well. Okay, so head off and try question 1 through 8 and question 13 and 14 from exercise 5.4.